Hello to Darkness344 here. Today I'm going to be showing you this very simple, well, you could say it's almost like a touchscreen display. So basically what happens is when you stand on the certain pixel, it will light up, as you can see. And this is pretty simple and a concept that's actually been used before. I just kind of got inspiration off of this because I've seen someone do this once with using 3 sculk sensors, one here and one here, and a bunch of comparators, just to kind of triangulate your position, and I thought that was very cool. I think also the Wild Java used one like this for his, I think he did like a paint program where he used one of these where you stand on the pixel, click a button and it'd paint it on your display. But these are pretty useful, and I guess I'm just going to show off how they actually work. So it seems very complicated with all this redstone over here, but in reality it's actually extremely very simple. So basically what you need for one of these, instead of using triangulation and all that kind of stuff, the very simplest method is just to use tripwire hooks like this. So of course, since this is just an example, my pixels are not really that dense. You have 1 pixel per 4 blocks, so 1, 2, 3, 4 blocks is a pixel, 1, 2, 3, 4 blocks and there's a pixel. I know that that's kind of a bad estimation, but yes, it's really 1 pixel per 4 blocks, and in reality you'd want your pixels as close together as possible like this, so you'd only have 1 lighting up like that. But just for an example, I've done it like this because it was a lot simpler to build. So what you basically need for this is an X and a Y axis. So you have your X along here, right, and you also have your Y along here. And so let's just use levers for example. If you have an X on 1 and a Y on 1, that means 1, 1 will light up. And if you could have an X on 2 and a Y on 1, that means 2, 1 will light up. It's pretty simple on how, that's basically simple coordinates. And that is what you can do with this display. But the way you get it to light up is you just basically feed it through an AND gate, like over here. So if this is 1, 1, I mean if this is 1 on the X and if this is 1 on the Y, when they both get hit, your light will light up. So we can use this to feed all these inputs into a massive bank of AND gates over here. So since we have 4 along the X and 4 along the Y, that means we multiply them together to make 16 different outputs. So as you can see, we have 4, 8, 12, 16. And then we can just feed these all into a bunch, well, 16 AND gates to be precise. So as you can see, we have these ones feeding into the top of the AND gates along these wires, and these ones over here, the wiring is kind of a bit complicated here, feeding into the bottom AND gates like this. And then we can basically just take the outputs of them and then feed them all the outputs all the way back into the display, into these pixels over here. So it's very simple, and hopefully you should, well, hopefully you got that from the explanation, but I'll just show you the AND gate that I've been using there. It's quite a simple one. I think it's like this. And it just makes things a bit easier than using a flat one like this, where it means you can have an input coming from here as well as an input coming from here. So like this, it means you can actually have buses, data buses like this. And it just makes things a bit more simple. So if I turn this one on and turn this one on, it will turn on. But if only one of them's on at a time, or they're both off, it will not turn on at all. And you can just, it's basically a big decoder to decode which one's on and the other one which is on, and it will give you a nice output. So I hope you got that, and it's just a pretty simple concept. And I guess, yeah, thanks for watching, please like and subscribe, and I am out. See you next time.